along x-axis. So we have to find the even and odd part of the signal. So even part of the signal is given as x of t plus x of minus t divided by 2, which is nothing but 0.5 times x of t plus x of minus t. Okay. So, and odd part of the signal is given as xo of t, which is nothing but x of t minus x of minus t divided by 2, which is nothing but 0.5 times the amplitude into x of t minus x of minus t. Correct? So, to plot the even part, what you do, you will add the signal with the time reversed part and you divide the amplitude by 2. You scale the amplitude to half, right? Whatever it is. Similarly, for odd part, you will subtract the signal with its time reversed part. Here you will add it, here you will subtract it. Then you will scale it to amplitude half. Okay, so we shall see x of minus t. So x of minus t means whatever is in the right will come to the left and whatever is in the left will go to right. That's mirror image or folding. Okay, if you fold a signal about vertical axis or y axis, what happens, that is nothing but time reversal. Okay, so at the right side you have a signal from 0 to 3 that will be reflected to the left side, and left you have minus 2 to 0 that will be reflected to the right side. Okay, that is time reversal. So we shall see that 1 and 2, you have minus 1, minus 2 and minus 3, and you have a signal like this. Okay, this is your time reverse signal with amplitude 1. This is time period, okay, along x-axis. So now we'll add these two signals, okay, to find the even part of the signal. I'll add this side only. So you have x of t plus x of minus t. So at t is equal to 0, what is the signal amplitude?
2.
So at t is equal to 0, you have amplitude for x of t as 1, for x of minus t as 1. So for x of t plus x of minus t at t is equal to 0 is 1 plus 1, it is 2. Okay. So this is 1 and this is 2. Fine. So your signal is here 2. Now at 1 you see a time instance 1. So what is the signal at amplitude at 1? For x of t it is 1. Similarly for x of minus t also it's 1. So it's 2. Okay, 1 plus 1 it is 2. So this will continue like this. Okay. So again at 2 you see, you check at t is equal to 2, you have amplitude 1 here and you have 0 here. Okay, so 1 plus 0 is 1. So at 2 the signal will come to 1. Got it? Are you guys following? And check at 3, you have 0 plus 0, so it is 0. So at 3 it will come back to 0. Got it, everyone?
Yes, ma'am.
So your even signal will be, in even signal x of t will be equal to x of minus t for all the values of t, and it will be symmetric about y-axis. So this signal will be symmetric and the left side also it will be the same. So left side you observe here at t is equal to minus 1 you have 1, amplitude 1 for x of t, and for x of minus t also you have 1. So it is 2, amplitude is 1 plus 1, it is 2. So the signal will continue at x is equal to minus 1. Okay, it will be 2, and so at t is equal to minus 1 it will be 2. Now go to x of t at minus 2. Okay, at minus 2 the signal is 0, and here at for x of minus t at minus 2 it is 1. Okay, so at minus 2 it will come back to 1. 0 plus 1 it is 1. Okay, this is 1. Next, again at minus 3 you see the signal is 0 here and here also 0. So at minus 3 it will come back to 0. Okay, this is minus 3. Fine? Understood? Did you guys follow? Followed or not?
Yes, ma'am.
Yes, ma'am.
Now we have to get 0.5 times the amplitude, right? So you redraw this circuit, but I'll change it here only. 0.5 times this one means 2 by 2, 1 by 2. Okay, your signal will be from 1 to 0 to 1 amplitude. Okay. If you want me to draw, I'll draw. You have to draw okay. 0.5 into x of t plus x of minus t, or you can also write x of t plus x of minus t divided by 2. Okay, so that will be 1. And at 2 it will come back to 0.5. And at 3 it will come back to 0. Got it? This is 0.5. Understood everyone?
Yes, ma'am.
So we shall see the odd part. So we have to, and everyone understood? You want me to explain once again? Followed?
Yes, ma'am.
Others, it's clear?
Yes, ma'am.
Yes, ma'am.
So we'll plot the odd part of the signal, that is x of t minus x of minus t. Okay, so I'll draw it here. X of t minus x of minus t. So we have to subtract this signal and this signal. Okay, so at t is equal to 0, what you have? Amplitude of x of t is 1, and amplitude of x of minus t is also 1. So 1 minus 1, it is 0. So at t is equal to 0, it's at 0 only, and go to 1, t is equal to 1. So at t is equal to 1, what you have? X of t, amplitude is 1 here. At t is equal to 1, for x of minus t also you have 1. Okay, so 1 minus 1, it is 0 only. Fine, it is 0. Now you go to 2. Okay, at 2 you have 1, and at 2 here you have 0. So 1 minus 0 would be
1.
1. So at 2 it will go to 1. This amplitude is 1. Okay. Now go to 3. At 3 you have 0 and 0. So at 3 the signal will again go back to 0. Clear? Is it clear everyone? Now we shall plot the left side. Okay, negative values of t. So for t is equal to minus 1, the signal amplitude is 1 here. Okay. As you can see, at t is equal to minus 1, amplitude is 1. And for x of minus t, at t is equal to minus 1, the amplitude is 1. So 1 minus 1, it is 0. Okay. So at minus 1 also it will be 0 only. Next, go to minus 2. At minus 2 you have 0. And at here for x of t at minus 2 you have 0. For x of minus t at minus 2 you have 1. So 0 minus 1, what is that?
Minus 1.
Minus 1. Okay, the signal will be minus 1. Then again at 3 you see 0 minus 0. It is 0 only. So this minus 1 will go back to 0. Got it? So we have plotted x of t minus x of minus t. So for odd part of the signal, so x of t minus x of minus t divided by 2 you have to do, which is nothing but amplitude will be reduced to half. Okay, you have 1 there, the amplitude will be reduced to 0.5. So you have 1, 2, 3, minus 1, minus 2, and minus 3. So here you have 0 only, and here your amplitude is reduced to 0.5 instead of 1. Okay, and here also it's reduced to minus 0.5. Clear everyone? This is odd part of the signal XO of t. Clear?
Yes, ma'am.
So now we shall see the next problem, next homework problem which I had given. Everyone followed?
Yes, ma'am.
Yes,
Do you
ma'am.
have any doubts?
No. No,
So
ma'am.
if you have any doubts, you get it clarified. Okay, don't simply tell you followed. So next problem, we have to find the even and odd part of the signal. So I'm doing with respect to waveforms only because that is important. With respect to signals, it's very easy. With respect to an equation. So if you learn about signals, then it's very easy. With respect to waveforms, I mean. So you have x of t and 1, and you have 2 time period, and it's -1. So -1 to 1, you have a RAM signal. Then at 1, the signal is 1. Again, there is abrupt change. It goes to -1. Okay, and it comes to 2 later. So at 2, it goes to 0. Okay, this is the given signal. So you have to plot the even part and odd component, even and odd component, or even an odd part of the signal. So xe of t is nothing but x of t plus x of minus t divided by 2, and xo of t is nothing but x of t minus x of minus t by 2. So what is the first step? You will plot the mirror image first. Okay, mirror image of x of t. So whatever is in the right will go to left, and which is in the left will go to right, because we are folding the signal with respect to vertical axis or y axis. Okay, so draw the mirror image first. X of minus t. So you have 1. So amplitude is 1, and at -1 and -2, you have something like this. Okay, this is the time reversal of the signal. Okay, I have time reversed the signal, or I have reflected the signal, and I have got the mirror image. Now I have to add both the signals, x of t plus x of minus t, because I want the even part. Okay, I'll add it now. Just observe. So you have x of t plus x of minus t. So at 0, what is the signal? At time t is equal to 0.
2, ma'am.
So at time t is equal to 0, for x of t and x of minus t, the amplitude is 1, right? So 1 plus 1, it will be 2. So if this is 1, this will be 2. Okay, so the signal is at 2. Next, you plot at t is equal to 1. What is the signal? Okay, at t is equal to 1, for x of t and x of minus t, you observe. For t is equal to 1, you have a signal from 1 to -1. So first we will take from 1. First we'll take from 1 to 0. Okay, next we'll plot this part. Okay, so as you can see, at t is equal to 1, the amplitude is 1 here, and for x of minus t, it is 0 here. So the signal will drop to 1. 1 plus 0. This part have not yet plotted. So this is as it is. So just observe this upper part of the amplitude. So you have 1 here. 1 plus 0 is 1 only. So the signal at 1, from 2 it will come to 1. Okay, we are not yet completed because there is abrupt change here. The signal is going to -1. So -1 plus 0. What do you get?
-1.
-1. So the signal will go to -1. Okay. Next, again from 1 to 2, the signal is at -1, and here you have 0. So it will be like this. Okay. So this is the signal. Did you follow? Right side of the signal. Now, so we'll plot the left side similarly. So as you can see, left side also same way you have to plot. So at t is equal to 0, we have 1. So we have to next come to minus 1. Okay. So here you have at minus 1, the signal is 0. Right. So 0 plus 1 you do first. Okay. So 0 plus 1 is 1. At minus 1, the signal will come to 1. Okay. This amplitude is 1 here. It will come to 1. And as you can see here, at minus 1, it is 0 only. But here it's going to minus 1, right? There is abrupt change. So 0 minus 1 is, 0 plus of minus 1 is minus 1, right? So the signal at minus 1 will go to amplitude minus 1, okay? And again, from minus 2 to 2, you have amplitude minus 1 here and you have 0 here. So 0 minus 1 would be minus 1 itself. Got it? Did you guys follow?
Yes, ma'am.
Followed everyone? You want me to
Yes,
explain
ma'am.
once again?
Yes, ma'am.
Okay, so we have a signal x of t and x of minus t. So we have to add these two to get even part now, first part. So first we'll add this, later we'll scale the amplitude. So adding, if you do correctly, then you can scale it. Okay, so we have x of t plus x of minus t. First at instant t is equal to 0, check what is the amplitude. Okay, so at instant t is equal to 0, you have amplitude 1 and 1 here. So the amplitude at t is equal to 0 will be 2. Okay, and we don't know about 1 and minus 1, so just let it be at 2. Okay, next go to minus 1, go to plus 1. Okay, here the amplitude is 1. From 1 it's going to minus 1. Okay, so first you consider 1 only. Okay, so here the amplitude is 1 and here it is 0. So 1 plus 0 is 1, right? So at t is equal to 1, the amplitude will come to 1. Later you observe there is the change. The signal is going to minus 1 suddenly. Okay, so minus 1 plus 0 is minus 1 itself. So the signal will go to minus 1 here. Okay, here the signal at 1 will, from 1 it will go to minus 1. Okay, then again at 1 the signal is at minus 1. Okay, so minus 1 plus 0 is minus 1 only. Okay, at 2 it's 0. 0 plus 0 it's 0. At 2 it's coming back to 0. Similarly the left part also. So you have a signal here at t is equal to 0. You have 1 and 1. So we have done till here. So at minus 1 you see. So at minus 1 you have 0 here, and here you have the abrupt change from 1 to minus 1. So first consider 1 only. So at minus 1 it is 0. 0 plus 1 is 1. So at t is equal to minus 1, the amplitude from 2 will come down to 1. Okay. Then you can see 0 plus of minus 1. The signal is going to minus 1 here. Later part. Okay. There is abrupt change to minus 1. So 0 minus 1 is minus 1. Sorry, 0 plus of minus 1 is minus 1. So it will go to minus 1. Then from in between 1 and 2 it's minus 1. Here it is 0. So plot that as it is. Clear?
Yes, ma'am.
It's clear, everyone?
Yes, ma'am.
So now you have to plot the even part of the signal. So x of t plus x of minus t by 2 or 0.5 times the x of t plus x of minus t. So whichever is at 2 will become 1 and whichever is at 1 will become 0.5. So you have a signal like this. And here the amplitude will be minus 0.5. This is at 1, this is at 2, this is at 1, and this is minus 1 and minus 2. Got it? Just amplitude will be scaled by 2. Okay, which is at 2 will get compressed to 1 and which is at 1 will compress to 0.5. Here also, which is at -1, will compress to -0.5. Clear, everyone? X e of t, even part of t. Shall we move on to plot odd part?
Yes, ma'am.
Is it clear, guys?
Yes, ma'am.
Yes, ma'am.
Okay, we shall plot the odd part now. Yeah, so for plotting the odd part, we have to do x of t minus x of minus t. Okay, so we have to subtract these two signals. So observe, I have a signal x of t minus x of minus t. I'm subtracting these two. So I have from instant 1, 2, 3, I'll take -1, -2, -3. So whichever is the signal, first write the time instance like this. Then start evaluating from t is equal to 0. Okay, at t is equal to 0, the signal is 1, amplitude is 1 here for x of t. Whereas for x of minus t also it's 1. So 1 minus 1, it will be 0. Okay, so it will be 0. Next at 1 you evaluate. Okay, at 1 what is happening? Here the signal is at 1 and here the signal is at 0, right? So here it's at 1 and 0. So 1 minus 0, it's 1. Okay, so the signal will be at 1. Fine, this is 1. Then there is abrupt change here. Okay, so it's going to -1 here. So -1 minus 0 is -1 only. So the signal at 1 will go to -1. Okay, next you can see at t is equal to 1. Where is the signal? It's at -1. So -1 minus 0 is -1 only. And again at 2, it will get back to 0. Got it?
Yes, ma'am.
Followed?
Yes, ma'am.
Yes, ma'am.
So next, plot the left side. So go to t is equal to -1. So at t is equal to -1, as you can see, the signal is 0. Okay, and here it is 1 going to -1. Okay, first I told you to take first part, 1 you take. Okay, next we can change it to -1. So here 0 minus 1. So the signal at -1 is at 0. Here it is at 1. At -1 it is at 1. So 0 minus 1 will be
+1.
0 minus 1.
Minus 1.
It will be -1.
Minus
Correct.
1.
It will be here at -1. Then what is happening? Here it is at 0 and here it's going at -1. So 0 minus of -1.
+1.
So the signal will go to +1. Okay. Then again from 1 to 2 it is 0 minus of -1. So it is +1. And at 2 it will get back to 0. Understood? Did you guys follow?
Yes, ma'am.
Yes,
Do you
ma'am.
have any doubts?
No, ma'am.
You want me to explain once again? Clear? Just you have to subtract the amplitudes here. Okay, whereas in previous part you will add the amplitudes. Okay, here you will subtract the amplitudes. Okay, but here in the signal I have given you the amplitudes changing from 1 to -1. So it might be a little confusing. So as I told you, take the first part first, then take the second part. Okay, so I'll explain you once again. Listen if you didn't understand. So you have x of t and x of minus t. We have to subtract x of t with x of minus t. So x of t minus x of minus t, you write, and at t is equal to 0 will start. Okay, always start a signal from t is equal to 0 and plot the right side part. If you plot the right side part, you'll get the idea of the left side also. For even it will be symmetric, for odd it will be anti-symmetric. Okay, you'll get an idea. Fine, if you get confused also, somehow you can manage. Okay, so first plot at t is equal to 0 you check. you have 1 minus 1, you have 0. Okay, at t is equal to the signal is 0, then go to 1. Okay, at 1 the signal is from plus 1 to minus 1, and here it is at 0. So take a plus 1 first. Okay, so it is 1 minus 0, it is 1. Okay, the signal is at 1. Then at 1 it's changing from minus, there is abrupt change to minus 1, right? So it is minus 1 minus 0, it's minus 1. Okay, so then at t is equal to 1, you have minus 1. So minus 1 minus 0 is minus 1 only. And at 2, what is the signal? It is 0. So here also it's 0, so it's coming back to 0. So if you get this part, right side part correct, so for odd, you have to plot it anti-symmetric. Okay, it's the same. So you just follow the amplitudes and you'll get this part also. Okay, is it clear? So here at t is equal to, for x of t at t is equal to minus 1, you have 0, and here you have 1. Okay, 1 and it's going to minus 1. So 0 minus 1 would be minus 1. Okay, and 0 minus of minus 1. Here the signal is at minus 1. So 0 minus of minus 1 would be plus 1. So the signal is coming back to plus 1 here. Okay, again at 2 we have the signal 0. Okay, so from between minus 1 to minus 2, here it is 0, right? But here it's minus 1. So 0 minus of minus 1 is 1 plus 1. Okay, and at minus 2 the signal you have 0. So it's coming back to 0. Clear everyone?
Yes, ma'am.
Others, it's clear?
Yes, ma'am.
So one trick for verifying it's correct or wrong is first you plot this from 0, t is equal to 0 to positive values of t, and for even signal it will be symmetric. Okay, whereas for odd signal it will be anti-symmetric about x-axis, sorry, y-axis. Okay, so for even it will be symmetric, for odd it will be anti-symmetric about y-axis or vertical axis. Clear everyone? Is it clear?
Yes, ma'am.
So I'll give you one problem with waveform, sorry, with the equation. You try solving that. So find the even and odd components of the signal. So x of t is equal to cos t plus sin t plus cos t into sin t. So how will you solve? This is an equation form. How will you find the even and odd components of the signal? So this is a signal or an equation. You have to find the even and odd component of this signal. How will you find?
Ma'am, first we have to find x of minus t, ma'am.
Yes, first find x of minus t. So wherever you have t, replace it with minus t in this equation. Okay, so you have cos of minus t plus sin of minus t plus cos of minus t into sin of minus t. Now we know that what is cos of minus theta?
Cos theta.
It's cos theta only. So cos of minus t is cos t only. So it's cos t. What about sin of minus theta? It's minus sin theta. So sin of minus theta is minus sin theta. So minus sin t. What happens to this? This is cos t only. This will be minus sin t. So I'll write minus cos t into sin t. Okay, this is your x of minus t. Now what is x even part of the t, which is nothing but x of t plus x of minus t divided by 2. So we'll try to solve it. So this is x of t, this is x of minus t. We'll try to solve it. We shall see what we get. So x e of t is nothing but, I'll take half here. So what is x of t? It's cos t plus sin t plus cos t into sin t. What about x of minus t? It's plus cos t minus sin t minus cos t into sin t. So whichever is positive and negative, that will get cancelled, sin t and minus sin t plus cos t into sin t minus cos t into sin t will get cancelled. So x e of t is nothing but half into 2 times cos t. So half and this 2 will get cancelled. So cos t. Even part of the signal is cos t. Got it? Did you follow?
Yes, ma'am.
Everyone followed? Just
Yes.
change t to minus t, depending if it's a cosine.
Yes, ma'am.
Cosine is an even signal, right? So if x, what is the condition for even signal? X of t is equal to x of minus t for all the values of t. So one best example for even signal is cos t. Whereas for sin t, for odd signal, x of t is equal to minus x of minus t or minus x of minus t, or x of minus t is equal to minus x of t. This is the condition for sine wave, right? Odd signal. So best example for odd signal is your sine wave. Okay. So sine of minus theta is minus sine theta. So that is what we have done. Depending upon its cosine or sine, it's even and odd. Just write it and you have to solve it. Similarly, do for odd signal xo of t. What do you get?
And sin t plus cos t into sin t.
Yes, sin t plus cos t into sin t. So we shall see that. So we have half into x of t minus x of minus t. Okay. So what is our x of t? Our x of t is cos t plus sin t plus cos t sin t, right? So cos t plus sin t plus cos t into sin t minus, we have to subtract the x of minus t. Okay, x of minus t, what is that? It's nothing but cos t minus sin t minus cos t into sin t. So we have a negative sign. So cos will become negative, whereas sin t and minus cos t sin t will become positive. Okay. So we have minus, I'll multiply with negative sign. Okay. So minus cos t plus sin t plus cos t into sin t we have. Okay. So as you can see, plus and minus cos t will get cancelled. So you are left with 2 times sin t plus 2 times cos t into sin t. So take 2 common, you will get sin t plus cos t into sin t. This is the odd part of the signal. Got it, everyone?
Yes, ma'am.
Clear?
Yes, ma'am.
So I'll give you one problem. You try solving this. Find the even and odd components of the signal. So you have a signal x of t, and it is like this. From -2, the amplitude is 4. Again, up to 2, the amplitude is 4. This is a given signal. Try to find the even and odd components of the signal. Try solving this. So we first will plot the time reverse signal x of minus t. So the signal is from -2 to +2 with amplitude 4. So this is the time reverse part of the signal. So we have to plot the even and odd components. X e of t is equal to x of t plus x of minus t divided by 2, and x o of t is nothing but x of t minus x of minus t by 2. Okay, so first we'll try to plot the even part, x of t plus x of minus t. So at t is equal to 0, what is the amplitude?
4, ma'am.
8, ma'am.
8,
At
ma'am.
t is equal to 0, the signal amplitude is 8. Okay. Then at t is equal to 2, you see. At t is equal to 2, what is the amplitude again?
4, ma'am.
It's 4, right? Then how do we plot it? This is 4. Again, the signal will be like this. Okay. So for left side also it's the same. So at -2 you have 0 plus 4. Okay. So at -2 you'll have the amplitude at 4. It will reduce to 4 and it will come back to 0. Okay. This is the x of t plus x of minus t. So x of t, this is x of t plus x of minus t. So if you want the even part, divide it by 2. So at 8, the signal will compress to 4, and which is at 4 will compress to 2. Okay, you redraw the circuit. Sorry, redraw this diagram again. Next, we shall see about xo of t. X of t minus x of minus t. So at t is equal to 0, the signal is, amplitude is 4 for x of t, whereas for x of minus t also it's 4. So 4 minus 4, it will be 0. Okay, then at 2 and -2 we have to check. So at 2, what is happening? At 2, what is the amplitude?
4, ma'am.
Minus 0. Okay, so 4. So it will go to 4 and come back to 0. And similarly, at -2, what is the amplitude? It is 0. And at here, what is the amplitude? Here it is 0. Here it is 4. So 0 minus 4, it will be -4. Got it? So if you want to plot the odd part, multiply it with 0.5. So amplitude will be scaled to +2 and -2. Understood, everyone?
Yes, ma'am.
Is it clear? So we have solved even and odd components of the signal with respect to continuous time signal. Okay. With respect to discrete time signal, I'll solve it in future classes. Okay. So next I'll start with energy and power signals. After we complete energy and power signal, we can solve this even and odd components of the signal with respect to discrete time signals. Okay. The signals will be in a discrete form, and we have to find the even and odd components of the signal. Fine. So now we'll start with energy and power signals. Till what time can I take your class?
Mom, we have next class from 11:15 now.
Who will take at 11:15? It's my class only, no?
Yes, ma'am. Oh, yes, ma'am. It's yours only.
My class only, right? Okay. Shall I leave you at 11:45?
Okay, ma'am.
Yes, ma'am.
So 15 minutes break you will have. Okay. From 11:45 to 12:10, right? Yeah.
Ma'am, we are taking 2 classes.
I'll take till 11:45. Okay. Because many of my classes are clashing with exam. We have exam duties for first years. Okay. Many it's clashing. So tutorials, whenever Thursday's tutorials class, right? So 15th I'll have tutorials class. So I'll not be able to engage that 3 to 5. Instead of that, I'll take from 8 to 9. Okay. Thursday, Friday, I'll take at 8 to 9. And 22nd also I'll take from 8 to 9. Okay.
Okay,
Thursday
ma'am.
I have 2 hours, right? Thursday I have from 3 to 5. That is 255 to 4:45, I think. So to compensate for that tutorials, today I have taken some extra. And next Friday I'll take from 8 to 9 also, 23rd. Okay, other classes will be the same. Only 15th, 16th and 22nd I'll take from 8 to 9 classes. Okay. Other days you'll have normal time only. So yes, tomorrow's tutorials I have compensated today. I have taken some extra class. Okay. Next tutorials is 22nd. No, that I'll take 8 to 9, and 23rd also I'll take 8 to 9 and 9:50 to 10:45. So that we'll not miss any classes and the syllabus will be going in pace. And now we shall start with energy and power signals. So for energy and power signals, you have some equations.
Now,
Yes,
so now you will take class up till when, ma'am? 11:45.
11:45.
Okay, fine.
Okay. So for energy and power, there are two types of signals. Okay, energy signals as well as power signals. So you people know basic classification of signal is discrete time signals and continuous time signals. So there are energy and power equations for both these discrete time and continuous time signals. So you have equations. Okay, that equations you have to know. You don't have derivations for equations. Just you have to know the equations for this. Okay. So we have two types of signals, discrete and continuous time. So we shall see the energy signals and energy equations and power equations for these discrete time and continuous time signals. So the signal is said to be energy signal if its normalized energy is non-zero and it's finite. Okay. So a signal is said to be energy signal if its normalized energy is finite. Okay, and it's non-zero. So that means if energy is greater than 0 and less than infinity, that's called an energy signal. Okay, so the equation for continuous time, energy equation for continuous time signals is E is equal to minus infinity to infinity modulus of x of t square into dt. So this is energy equation for continuous time signals. Okay, coming to discrete time signals, the energy equation is E is equal to summation of n is equal to minus infinity to infinity x of modulus of x of n square. Okay, this is energy equation for discrete time signals. So this is important. Okay, you have to know this. What is the equation for continuous time energy and discrete time energy? So for continuous time signal, energy is given by integration with limits minus infinity to infinity and taking the modulus of x of t and squaring it. Okay, so you have x of t square into dt. Okay, whereas for discrete time signal, energy is the summation. Okay, it's summing from samples from minus infinity to infinity and the magnitude of square, modulus of square. Okay, so E is equal to summation n is equal to minus infinity to infinity x of n whole square. Okay, this is the energy equation. So always energy signals will be non-periodic. Okay, so wherever you find non-periodic signal which is not periodic, it's not repeating at equal intervals of time, then it is you have to find energy of that signal. Okay, they'll tell you to find energy or power of the signal. So for energy signals, you have to know what is the power. Okay, for energy signals, power will be equal to 0. Okay, whereas we will see for power signals. Okay.
Can you repeat what is energy signal and power signal?
Yeah, I'm explaining about energy signals. So energy signals are basically non-periodic. Okay, so energy signals, if you find any non-periodic signal, then you have to find energy of that signal. Suppose if it's continuous time signal, then use this equation. E is equal to integral minus infinity to infinity x of t modulus of x of t whole square into dt. Okay, where if it's discrete time signal, then use this equation. E is equal to summation of n is equal to minus infinity to infinity. You're summing the samples, okay, from minus infinity to infinity x of n whole square. Fine. So I'll tell you the difference, how to identify energy and power signals. So first you understand the equations for this. Okay, this is the equation for continuous time signals. Energy is given by this equation, integral minus infinity to infinity x of t whole square into dt. Okay, whereas for discrete you have summation of samples from n is equal to minus infinity to infinity x of n whole square. Okay, modulus of x of n whole square or magnitude of x of n whole square. So we'll come to power. Similarly, power of a signal is non-zero. If a power of a signal is non-zero and finite, then the signal is called power signal. Okay. So if the power of the signal is non-zero and the signal is finite, if the power of the signal is non-zero and finite, then it's called a power signal, which means 0 less than E less than P less than infinity. So if the signal, so for power of a signal is non-zero, if the power is non-zero and it's less than infinity, that means if it's finite, then it's called a power signal. Okay. So energy signal and power signal definitions are same. Okay, for energy signal, energy is non-zero and it's finite, whereas for power signal, power is non-zero and power is finite. Okay, it depends on how you identify the energy signal and power signal and find energy or power. Okay, so for this power signal, you have two types. Okay, so continuous time and discrete time. There also you have periodic and non-periodic signal equations. Okay, so first we'll see for continuous time non-periodic. For continuous time non-periodic signal, the power is given as P is equal to limit t tends to infinity minus t by 2 to t by 2, or you can write 0 to t, okay, x of t square into dt. This is for continuous time non-periodic signals. Whereas for continuous time periodic signals, take down the equation.
And the energy equation is the same for continuous, periodic and non-periodic.
No, you have 1 by t here. Limit t tends to infinity 1 by t.
Energy equation.
For energy equation,
You have written only, it is for both periodic and non-periodic.
yeah, energy signals will be non-periodic. I told you, right? Non-periodic signals, you'll find energy. Okay. I'll tell you the difference. When we solve problems, you'll get to know. So energy signals will mainly be non-periodic signals only. Okay. They'll be existing for finite value of time. It will have finite energy. Yeah, power is nothing but energy by time, no? So you have limit t tends to infinity 1 by t integral minus t by 2 to t by 2 x of t square into dt. Okay. So for continuous time periodic signals, the power equation is P is equal to 1 by t 0 to t x of t square into dt. Okay, this is the power equation for continuous time periodic signals. Similarly, we have for discrete signals also. So for discrete time non-periodic signals, the equation is P is equal to limit n tends to infinity 1 by 2n plus 1 into summation of n is equal to minus n to plus n x of n square. Okay, this is for discrete time non-periodic signals. For discrete time periodic signals, the equation is P is equal to 1 by n, summation of n is equal to 0 to n minus 1, x of n square. This is for periodic signals. To take down these 4 equations, we'll be using this for solving problems. Okay. Energy and power of the signal. So we have different equations for energy as well as power. So you people know that energy is nothing but power into time, or power is energy by time. Did you all take down? Yes.
Can you scroll a little bit down, ma'am?
Yeah. So what happens to energy of power signals and power of energy signals?
That upper limit is n minus 1 ma'am in discrete periodic.
Yes, n minus 1. So just think what happens to energy of power signals, energy in case of power signals and power in case of energy signals. For energy signals, power will be finite. Okay. So no. For power signals, power will be finite. If I multiply with time minus infinity to infinity, what happens to energy? Energy of power signals, I am telling you. Energy of power signals. What happens to energy of power signals?
Infinity, ma'am.
It will be infinity. Okay. Similarly, what is the power of energy signals? Power is
Zero,
equal to energy will be finite. Okay. So time will be minus infinity to infinity. Okay. So what happens to power? Power will be 0. Okay. This you have to know. The power of energy signals will be 0, whereas energy of power signals will be infinity. Okay, you make note of this. Shall we start solving problems? Clear, everyone?
Yes, ma'am.
You have 2 types of signals, that is continuous time and discrete time. So there is one more classification of signals, energy signals and power signals. Okay. So you have energy for continuous time signal and energy for discrete time signal. Okay. So energy for continuous time signal is given as integral minus infinity to infinity x of t whole square into dt. Okay. Whereas energy for discrete time signal is given as summation n is equal to minus infinity to infinity x of n whole square. Okay. Similarly, you have power signals. Energy signals will be finite. Energy signals will have finite energy and it will be non-zero. Whereas similarly, power signals will be non-zero and finite. Okay. So you have 2 types of signals, right? Continuous and discrete time. So we have power equations for both continuous time, discrete time, periodic signals and non-periodic signals. Okay. So continuous time, non-periodic signals. This is the equation. P is equal to limit t tends to infinity 1 by t integral minus t by 2 to t by 2 x of t whole square into dt. Whereas for periodic signals, whereas for continuous signals, power is given as 1 by t integral 0 to t x of t square into dt. Coming to discrete time non-periodic signals, power is given as P is equal to limit n tends to infinity 1 by 2n plus 1 summation n is equal to minus n to plus n x of n square. Whereas for discrete time periodic signals, you have power P is equal to 1 by n summation n is equal to 0 to n minus 1 x of n square. And you can observe here that energy is nothing but power into time. Okay. So for a power signal, power will be finite and it will be non-zero. What happens to energy of power signal? So energy of power signals will be infinity and power of energy signals will be 0. Okay, this you have to note. And shall we start solving problems? Clear till here?
Yes, ma'am.
What about others?
No, energy signals are finite or
Energy will be finite.
and
Okay.
it also non-zero.
Yeah. Energy will be non-zero and finite. Okay, whereas periodic signals will be power signals always, and we'll find power for one period. When we solve problems, you'll get an idea. Okay, so first we shall see, and we shall see a problem. You identify which type of signal it is. X of n is equal to 1 by 2 to the power of n into u of n. So what type of signal is this? So how will the signal look? First you have to see. Your x of n, they are telling you half to the power of n into u of n. What is u of n?
Discrete signal.
Yeah, what type of signal is that? It's unit step, right? U of t, you have come across u of t. This is u of t. What is u of t? It's unit step. So it will exist from t is equal to 0 to infinity, t is equal to infinity with an amplitude 1, right? Yes or no? Unit step. This is unit step signal in form of continuous time. This is continuous time signal. This is discrete time unit step signal. Okay, so how will the signal look? The amplitude will be 1 from t is equal to 0 up to infinity. This is 1, amplitude 1. Got it? Till infinity, the amplitude will be 1. Understood?
Yes, ma'am.
Clear, everyone? So this
And can you
is
repeat it, ma'am?
unit step signal, right? We know the definition of unit step, right? So what is the definition of unit step? U of t. We have seen in last time, right? In unit 4, we have discussed about unit step, unit ramp, impulse signal, right? 3 types. Here also we'll be discussing about these 3. But in the problem, we have energy. In energy of power signal problem, we have like this. So unit step is nothing but it's 1 for t greater than or equal to 0. It is 0 for t less than 0. This is a unit step signal. You have 3 types of elementary signals in your syllabus. Okay, first one is unit step, unit ramp, and impulse. You remember this u of t, r of t, delta t. So here we'll be using these signals for solving problems on operation of signals. Okay, I'll discuss about elementary signals once again. So just we are solving one problem on energy power. We are coming across this. So I'm explaining you this topic. Okay. So unit step signal will exist from 0 up to infinity with an amplitude 1. This is with respect to continuous time. Okay. Whereas for discrete time, how will your unit step look? It looks something like this. 1, 2, 3, 4 up to infinity. Okay, the amplitude will be 1. From 0 up to infinity, amplitude will be 1. I'll write the definition here also. U of n is equal to 1. For n greater than or equal to 0, it is 0 for n less than 0. Got it? U of n?
Yes, ma'am.
Clear, everyone? What is u of n, u of t?
Yes, ma'am.
Clear, guys? It's clear or not? You tell me.
Yes, ma'am.
So they have given you half to the power of n into u of n. That means yes, you have any doubt? So x of n is nothing but half to the power of n into u of n. They're telling you half to the power of n into u of n. That means the signal is existing, this half to the power of n exists from 0 to infinity. Okay, not for negative values of n. It will exist only for positive values of n, because unit step signal will exist from 0 up to infinity. U of n is from 0 up to infinity, amplitude is 1. So how will the signal look? Half to the power of n into u of n. So at 0, n is equal to 0, what will be the signal? Half to the power of 0 into 1. What is that? Amplitude?
0.5.
Half to the power of 0.
One, ma'am.
One, ma'am. It's 1, right? So half, I'll explain you once again. I'll give the values of n and you can take down that. So n is equal to 0. So what is x of n? Which is nothing but half to the power of 0 into u of n. Okay, u of n is 1 only, right? So need not write that. You can into 1 you do. What is half to the power of 0?
1, ma'am.
It's 1. So at n is equal to 0, the signal is 1. Okay, it's 1. And n is equal to 1. So it is half to the power of 1 into 1. So what is n? What is your, at 1, what is the signal? Amplitude?
0.5.
Half, right? So the signal is half here. At 2, at n is equal to 2, half to the power of 2, which is nothing but 1 by 4, right? At 3, n is equal to 3, half to the power of 3, or 1 by 8. So this is 1 by 4. Then you have 1 by 8. Then at 4, n is equal to 4. What is the signal?
1 by 16.
1 by 16. So what type of signal is this?
So what is the question, ma'am? What you have to find?
You have to find energy or power of the signal.
Yes, ma'am.
So what we are doing now, we are trying to plot this x of n. First, if we plot this x of n, we'll get to know what we have to find. If we have to find energy or power, we will get to know. Okay.
Yes, ma'am.
First, we are trying to plot x of n. I have explained you what is u of n, right? It is unit step. Half to the power of n, we are giving different values of n, and we are trying to get how, we are trying to see how the signal looks. X of n. X of n will look like this. They have given you equation form. Graphically, the signal will look like this. Okay. What type of signal is this? The amplitude is diminishing, right? It is becoming less. Correct.
Sine wave.
It's sine wave. How will sine wave look? How will sine wave look? Sine wave amplitude will be high. It will be less. Again, it will go to negative values. Again, it will become high. Right? Sine wave will look like this. Here, what you have? Amplitude is 1. It's less. It's becoming less. Amplitude is diminishing, right?
Damping
Beating
signal.
exponential.
Guys,
Triangle.
it's not triangle. It's
Decreasing exponential.
it's decreasing, right? Amplitude is decreasing, correct? At 0 it was 1, at n is equal to 0 it was 1, at some value of n it will approach in 0, at n is equal to infinity the amplitude will be 0, correct? This is our x of n. Are you guys following? The amplitude is diminishing or becoming less for increasing values of n. Can you observe this? Or this diagram is not clear for you? I'll draw it once again. Is it clear? So x of n is equal to half to the power of n into u of n is something like this. I'll draw the bigger diagram. X of n is half to the power of n into u of n. If n is equal to 0, your signal is 1. At n is equal to 1, the signal is half. Correct? It's 0.5. That at n is equal to 2, it's 0.25 amplitude. At n is equal to 3, 1 by 8. How much is that? 1 by 8. And n is equal to 4, it's 1 by 16. And it goes on, it becomes less for increasing values of n. What type of signal is this? It's periodic or non-periodic signal?
Non-periodic.
It's exponential, right? It resembles exponential signal. It's periodic or non-periodic?
Non-periodic.
It's non-periodic signal. For non-periodic signals, you have to find energy. Okay? So we shall write the energy equation. What is energy equation for discrete time signals? Summation of n is equal to minus infinity to infinity x of n whole square. Right? So what is our x of n? Half to the power of n into u of n. Correct? So this is the equation form of x of n. Graphically, the signal will look like this. Okay, to see this half to the power of n u of n, it will resemble like this. Okay, at n is equal to 0, amplitude will be 1. And it will go, amplitude will be 0 at n is equal to infinity. Fine. So we'll try to solve this problem. So from where to where the signal will exist? Because you have u of n, the summation limits would be from 0
to infinity.
Infinity. Okay. So n is equal to 0 to infinity. So what is our x of n? It's half to the power of n and u of n is 1 whole square. Correct? We are finding energy of the signal. Okay. So first what they are telling you, find the energy or power of the given signal they'll give you. They'll not specify find energy or find power. They'll give you find the energy or power of the given signal. So first, to find if it's energy signal or power signal, you have to plot it graphically. For your understanding, plot it graphically. Then it's non-periodic signal. So you have to find energy. Okay, so we'll try to find
Yeah, we
energy.
can find power also, ma'am, for non-periodic.
See, it is finite and it's non-periodic. Okay, it's finite, right?
Ma'am, we have given equation for non-periodic power equation.
I'll show you that type of problems also, but this signal is finite and it's non-periodic.
Power is also finite, ma'am.
So how to tell that? So I'll show that type of problem also for you. First, this is energy signal. Okay, so this signal will look something like this. Okay, it has finite energy. Okay, and it's non-periodic signal. So if it's finite signal and it's non-periodic, then you have to find energy of a signal. This is energy signal. Okay, we shall come across that also, which you told me. I understood. Okay, first we'll find energy of the signal. So if you have finite signal with non-periodic signal, finite and non-periodic signal, they have to find energy. So we have u of n. So we have put summation limit 0 to infinity. And our signal is half to the power of n into u of n. U of n is 1 because amplitude is 1 from 0 to infinity. I have written 1 here. Then I have written half to the power of n as it is here. Okay, so we have 0 to infinity now. So I can write this equation like this. Summation n is equal to 0 to infinity. Like this, can I write? I'm just replacing that. So you get summation n is equal to 0 to infinity 1 by 4 to the power of n. Okay, I have just rewritten this so that I can solve it. So what type of equation is this? Summation n is equal to 0 to infinity alpha to the power of n. What is the equation you have? It's a geometric progression equation, right? What is the equation for this? This is a geometric progression, right? Summation n is equal to 0 to infinity. Alpha to the power of n would be 1 by 1 minus alpha. Okay, so this alpha here is 1 by 4 here. So how do we go about to solve this problem? So we have got it in the form of GP, that is geometric progression. So you have to solve it because we have got it in this form. It will be 1 by 1 minus 4. 1 by 4. Okay, 1 by 1 minus 1 by 4, which is nothing but 4 by 3 joules. Clear? Is it clear, everyone? Yes or no?
Yes, ma'am.
So
Yes,
as of now, you understand that if the signal is finite signal and non-periodic, okay, it has diminishing amplitude, it is non-periodic, then it's energy signal. Okay, you understand like this step by step. We'll understand energy and power signals in detail. Okay, in coming classes. So this is energy signal. Okay, because it has diminishing amplitude. Okay, its amplitude will reach 0 at n is equal to infinity. Okay, and it's finite signal, so it's energy signal. Okay, so we go about to find energy of this signal, discrete time signal. So summation limits would be 0 to infinity because you have unit step there, u of n. U of n is nothing but it's a signal which exists from 0 up to infinity with amplitude 1. Akshay, could you mute your audio? So you have u of n which exists from 0 to infinity. So we have written the limits. The signal will exist from 0 to infinity only because it's multiplied with u of n. Okay, so u of n is 0 for n less than 0. It exists only from 0 to infinity. So the signal limits would be 0 to infinity, half to the power of n into 1 because amplitude of u of n is always 1. So I can rewrite this to get it in geometric progression form. Okay, this is the equation for GP. Summation of n is equal to 0 to infinity. Alpha to the power of n is 1 by 1 minus alpha. So I have alpha, my alpha is 1 by 4. So I get 1 by 1 minus 1 by 4, which is nothing but 4 by 3 joules. Clear? Clear, everyone?
Yes, ma'am.
So we'll solve one more problem. So find the energy of x of t. So your x of t is nothing but a rectangular signal. Okay, x of t is nothing but rect t by t naught. It's a rectangular signal. Okay, so you have t naught by 2 here and minus t naught by 2 here. Okay, this is a rectangular signal. So you have to find the energy of this. This is a continuous time signal. Okay, previously which we saw is discrete time. This is continuous time. So what is the equation for energy? Integral minus infinity to infinity sum modulus of x of t whole square into dt. So what are our limits? The signal is existing from minus t02 to plus t02. So it is minus t02 to plus t02, t0 by 2. So what is the amplitude for this? It's 1 here. Okay. So what is x of t? It's a rectangular signal with amplitude 1. So it's 1 square into dt. Okay. So integrating 1, what do you get? With respect to dt?
T, ma'am.
T with limits minus t0 by 2 to plus t0 by 2. So it will be nothing but t0 by 2 minus of minus t0 by 2, which is nothing but t0 joules. Clear? Suppose they have given you amplitude 1, they won't specify amplitude. So that time how will you do? Just try this, okay? Suppose amplitude is A. What do you get? For the same signal, I give amplitude as A. Because amplitude is 1, you have got T0. If you have A here, what do you get?
A T0 will get, ma'am.
Just check once. What do you get? Energy E is equal to minus infinity to infinity x of t square into dt, right? So
A square T.
We'll get same, ma'am. Same, ma'am.
it will be a square, right? So amplitude is 1 here. We have written 1 square. So here what is the signal existing from minus t0 by 2 to plus t0 by 2? What is the amplitude? It's a square into dt. So a square into a square is a constant. So if you integrate 1 with respect to dt, you get t. Okay, putting the limits minus t0 by 2 to plus t0 by 2. So you get a square into t0 by 2 plus t0 by 2. Okay, t0 by 2 minus of minus t0 by 2. Okay, which is nothing but a square into t0. Okay, what is the energy? If you have amplitude A, energy would be a square into t0 joules. Clear? So if a signal is non-periodic in nature, it's energy signal. Okay, you want to keep that in mind. So I'll also teach you non-periodic power signals also. So that will be different. So as for now, you understand that it is a non-periodic signal. So we are finding energy of that signal.
No, for previous question, there will be find energy in the signal.
So if they give you find energy of the signal, directly you can find energy. Okay.
No, the numerical you did
in this one, after the power of n into u of n. So if they find energy of the signal, you can find energy. So if they don't give anything, I'm just telling you what to do. You have to find energy of the signal only. Sometimes, rarely they will give you find the energy or power. Find the energy or power of the given signal they'll give you. Okay, that time you have to find energy. And what is the power of energy signal?
0, ma'am.
Power will be 0. Okay, you do that. So suppose if they give an energy of the signal, then directly you can find energy of the signal using this equation. If they give you find energy or power, then you have to identify the signal graphically, how it looks. Then analyze the signal. It's finite signal and it's non-periodic, so it will come under the category of energy signals. Okay, so find energy of the signal and write power as 0. Clear, everyone? We shall see some more problems on this. Okay, I'll take some 2 more classes for these energy and power signals. It's little bit you have to understand and solve problems. Fine. Clear till here? Is it clear till here, everyone?
Yes, ma'am.
Yes, ma'am.
What about others? Whatever we have discussed today, is it clear?
Yes, ma'am.
Yes, ma'am.
Yes,
Have
ma'am.
any
Yes,
doubts?
ma'am.
Vinamrata, you're following?
Yes, ma'am.
Maithili?
Ma'am, I don't think she's there, ma'am. She was not well, so she's admitted to hospital.
Oh, is it? Okay, fine.
She'll come from Wednesday, next week, ma'am, I think.
Okay, fine.
Or Wednesday this week, I'm not sure.
Okay. Others clear?
Yes, ma'am.
Yes, ma'am.
Okay, so till here you practice some problems. Okay, so we'll meet again on 15th morning. Okay, I'll continue problems in energy and power signals. So if you written your name and USN, then we can wind up this class. Thank you, students.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, from tomorrow is a holiday, ma'am.
Yes, Vinamrata, you asked me something?
Ma'am, tomorrow is a holiday.
Yeah, tomorrow is a holiday. And day after tomorrow is also holiday. 13th and 14th is holiday.
Okay, ma'am.